Okay, so we're finding the volume of this bad boy here. All right. So x squared minus y squared equals a squared, and y equals a plus h. So a and h are both positive. Huh. And we're going around the y-axis. Okay, so if we're going around the y-axis, that means we have to be in an x equals situation, right? And so that means I'm going to take this first one and solve it for x. So the bummer about that is that x equals plus or minus the square root of that. So now I have to think a little bit. What does the graph of x squared minus y squared equals a squared look like? You guys wouldn't know that, would you? No, that would be if it was plus. No. And also no. It's called a hyperbola. It's a double thingy. So like if I graph, what? No, that's an ellipse. That would be if it was like 4x squared plus y squared equals a squared. Well, let's graph one so you guys can see that. So if I was to solve it for y instead, that would be y squared equals x squared minus a squared, and then take the square root of that, right? So let's just pick a value for a, just for funnies. 1.
Is a constant?
Yeah. So if you want 1, no, why would you think that? No, it wasn't. Can't call me a liar. Stay focused. So it was -1, right? No, that doesn't, because then it's 10 minutes later and we're off on some other thing. Okay, so I'm going to do both of these.
I know, crazy. You know what's crazy? That pose.
So, this is called a hyperbola. So it's not really a parabola. And it's supposed to be, one of them is this piece right here and the other one is this piece right here. Okay, it's a conic section. And the way that you find it, the graph of it, is if you make a little box, 1 by 1 box right here, and then draw in the diagonals, and then you kind of fill in some stuff in there, then that gives you the graph. Okay, so yeah, we didn't really study those, but this is a shape that you see every day virtually. It's not an X because this is curved. Anyone? Well, you should stop. Anyone recognize this shape? No. No. It is the shapes of the cooling towers in the Sapsup nuke thing. Obviously, not quite so, shapely, but it's the same kind of deal. Yeah. The sides of those are hyperbolic parabolas, and there's some reason that there's some reason why construction-wise those are really strong. Yeah, anyway, so that's what we got going here. And then what we're going to do is we are going to take this and also the line x equals a plus h. So, x equals a plus h is going to have the same slope of this, but the h is going to move it up a little bit, and we're going to rotate that around the y-axis. So, yeah, the h, because a plus h is going to, okay. So if I change the a value here, let's do that just for fun. Let's make it 7. 32 is too much. Wouldn't be able to see it. If I change this to 7, then hopefully you guys can see a little bit how that changes the shape of the graph. So you see it's got a little bit more curve to it now. because of the resolution of the calculator. In reality, it does come together. That's just a technology failure. And then this distance right here is the square root of 7, okay? Okay, so anyway, so we have to set up some sort of a integral to solve this, and I don't have any idea how to do that. So let's cheat and figure it out, shall we?
Well, I got a
No,
set
this
for
definitely
X.
will not be on your test. Okay, so it says the graph. It says the graph of x squared minus y squared equals a squared. Hello, hey. The graph of x squared minus y squared equals a squared is a hyperbola with right and left branches. So that's the graph that we were looking at. So the volume that we want to do, I wouldn't ask you guys to do this, and so don't sweat it very much. The integral that we would need to set up for this is, nope, from a to a plus h.
2 pi.
Okay, why do you say 2 pi?
Because it's, what am I trying to say?
I don't know, that's what I'm
it
asking.
it's from like negative a to a.
Oh, okay, so you're going to double it, you mean? So normally it would be pi, but you're going to do both sides, so you're going to double it. Okay, I like that a lot. So that's going to be 2 pi. And then randomly this says x
And then that's
times 2 square root of x squared minus a squared dx. I thought if we were around the y-axis, it would have been dy, but what do I know? Nope, not very much. Okay, so the fun part of this is, if it hasn't been fun already, I can't answer any questions because I don't know the answers to them. Yep, that's what I just said, but you were visiting with Tiana, so you missed the fact that I mentioned that and said I don't know why they're doing that. It's okay.
Well, at least I noticed that, right?
I guess so, yeah, maybe.
Just gonna go
Okay, so the tough part about this now, once we even have this set up, is that you can't just go to your calculator and solve this because you have a and a plus h. Is Colby on this? No, he's on a calculator. Okay, so then we have to actually do this by hand, okay? So I need to make a u substitution.
Do you want us to actually write this down?
Not really. No, this is kind of a,
Giant empty space.
sure. So I have to make a u substitution. Any guesses what u will equal? Love it. X squared minus a squared. So then du will be,
2x minus.
nope, 2x dx. Yeah, because the derivative of a squared, that's a constant, so it just cancels. And how cool is that? That we have a 2x and a dx right there.
Weird. What a
Okay? Yeah, what a clinky dink. So this then becomes the integral, or 2 pi times the integral of the square root of u du. Okay? All right, then let's change our limits of integration while we're at it. So if I plug a in here for our u substitution, what do I get?
I mean, a squared minus b.
Which is 0. Okay, because they'll cancel. Then I have to plug a plus h in there. That's not very much fun. A squared plus 2ah plus h squared minus a squared. The a squareds cancel, so this would be from 2ah plus h squared. That is awkward. The 0 was super, super happy, but that's not so cool. Okay, so now what's the antiderivative of the square root of u? Awesome. So it's going to be 2 pi times 2/3 times u to the 3/2. And that's going to go from 0 to that. To ah plus h squared. Okay, and so that gives us a final answer of 4/3 pi times 2ah plus h squared to the 3/2. Yep, that's how they have it in here. There's nothing else that you can do. Because if you plug in 0, you just get 0, right?
Yeah.
Okay. Okay, so that's not, oh, sorry, shouldn't have assigned that. 8.
It's okay, we forgive you.
I'll appreciate that, Mackenzie. Okay, what does 8 want?
It's like you erase your time volume,
Uh-huh.
and it's x equals 1 plus y squared, and then y equals x minus 3 plus the y-axis.
Y-axis.
Yeah. What did you say exactly? And you solve for x, right? I got the y-axis.
Yeah. So,
What I did, I added 3, but then I have to make the calculator.
okay, so x equals 1 plus y squared is going to look like this,
Yeah, 117 times.
right? And then y equals x minus 3 is going to look like this. So I'm taking this right here and rotating it around the x-axis, okay? So the farthest away, well, first we need to do our endpoint, our limits of integration. So I'm going to plug this into here and then solve for y. So y equals 1 plus y squared minus 3. So y squared minus y minus 2 equals 0. Okay, so that means I'm integrating from -1 to 2. Then I need a pi. And then I need the farthest away from the axis of rotation is x minus 3, and that's going to be that radius squared, minus the inside one, which is, oops, that's not x minus 3, sorry. Yep, should be y plus 3, sorry. Minus 1 plus y squared squared. dy. Okay, dy. Colby, you good? Sure. Yeah, that's rough. Okay. Days. Okay, 30. You wouldn't think so, but sometimes.
I mean, I've never, you should definitely take advantage if you have to.
Sometimes it seems like it takes weeks. All right, find the average value of the function f of t equals t sine t squared on the interval from 0 to 10. So first I'm going to find the value of the integral, and then I'm going to take that answer and divide it by 10. So I'm going to do the integral from 0 to 10 of t times sine of t squared dt. That's an easy calculator problem, but since we're doing this together, we have to do it the long way. So u equals t squared, which means du equals 2t dt. So that means I need a 1/2 in there, right, to get rid of this 2. And then that gives me t dt da 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 da. So that's sine of u to u. All right, antiderivative of sine is, oh, sorry, we're going from what to what? 0 to 100. 100. Deutsche. Yeah. Uh-huh. Helga? Because if you take 10 and plug it in there for t, then that becomes 100. And if you plug 0 in there for t, then that stays as 0. Okay, antiderivative of the sine of u is negative cosine of u from 0 to 100. So cosine of 100, yo no sé. So that's going to be negative 1/2 cosine 100 minus cosine of 0 is 1. So that's going to make this negative 1/2. So if I go minus negative 1/2, it's plus 1/2. Okay. So that's the value of the integral. But I want to find the average value of that, right? So I'm going to divide by 10, but that's awkward in this case, so I'm going to multiply by 1/10. And that will simplify to, do you want to factor out the 1/2 or distribute the 1/10? factor out the, just keep it, yeah, it's going to be the same either way. So you want to factor out the 1/2? Okay, so 1/2 times 10 is 1/20th, so this is going to be 1/20th times 1 minus cosine 100. I switched them around so that it wouldn't be anymore. Okay?
It's about 0.
1/20th, 1 minus cosine of 100 is, yeah, 0.007.
That's what I thought.
Oh, M.A. Hay. All right, any other preguntas? No?